Question 7. Can we predict annual household electricity costs in a specific region from the number of rooms in the house? Below is a scatter plot of annual electricity costs in dollars versus number of rooms for 30 randomly selected houses in Michigan, along with computer output for linear regression of electricity costs on number of rooms. Okay, so let's just label a couple things. So this value here is our statistic. It's the slope of the sample regression line. This is the standard error for that statistic. We call it SEB. This is the test statistic. And then this is the p-value. However, this is a p-value for a two-sided test. Okay. And then this looks like it's a scatter plot. So it has our two variables, number of rooms and annual electricity costs. Looks like, okay. Assume the conditions for inference have been met. If we test the hypotheses, HO, beta equals 0, so that's equivalent of no linear relationship. Versus HA, beta greater than 0, that means there's a positive linear relationship. Okay. At the alpha equals 0.05 level, which of the following is the appropriate conclusion? All right. Now, this is a one-sided test, right? We're just looking for evidence of a positive slope. And then this is a two-sided p-value. So the two don't correspond, okay? But it's very easy to get the p-value for a one-sided test. You can just divide this by 2. Okay. So let's just make a note over here. The p-value for a one-sided test would be 0.013. Okay. All right, now looking at all the answer choices, none of them have that p-value, right? The first two choices have the p-value that's associated with the y-intercept part of the equation, so we can just eliminate those because it's clearly not the right p-value. But the other three all have the two-sided p-value, which I find really strange. So I'm thinking that there's a typo in this question. Either one of these should have said 0.013, or perhaps maybe this should have said beta not equal to 0. Maybe they meant to do a two-sided test. Okay. Anyways, let's read the three choices that are left and just try to find the one that sounds the most correct. All right. C. Because the p-value of 0.026 is greater than alpha, all right, stop right there. That's not even true. The p-value is less than alpha. Remember, alpha is 5%. Okay. D. Because the p-value of 0.026 is less than alpha, okay, so that's technically a true statement, we accept the null hypothesis. That is very taboo language in statistics. You never say that you accept a null hypothesis. Okay, just like a jury would never give a verdict that the defendant is innocent. You never can prove whether somebody's innocent. It's either they're guilty or they're not guilty. Either you have enough evidence to convict them or you don't have enough evidence to convict them. So the same idea in statistics. Either you reject the null or you fail to reject the null. You never really make a statement about the you never make statements in terms of accepting the null. Reject or fail to reject. Okay, let's read E. The p-value of 0.026 is less than alpha. True. We reject the null hypothesis. That's the correct language. We have convincing evidence of a linear relationship between annual electricity costs and number of rooms in the population of Michigan homes. Okay, so this sentence has context. It has the two-sided p-value, which I don't necessarily agree with. I think it should be a one-sided p-value. But everything else in the statement is correct.